Okay, today we are going to learn about polar coordinates. Up until now, you have seen what's called the rectangular coordinate system, where we have the x-axis and the y-axis. The x represents the horizontal distance we move from the origin. The y stands for the vertical distance we move from the origin. We are now going to look at what's called the coordinates, or the polar coordinate system. Okay. Instead of our point being x comma y, we are now going to have r comma theta, where r is the directed distance from the pole, or what is considered the origin. All right, so right here, this is what we call the pole instead of the origin. So r is the distance from that pole, and theta is the directed angle, counterclockwise of course, from our polar axis. So this positive x-axis, this is what we consider our polar axis. We're going to rotate from there just like we're used to rotating from with our rotational angles back in chapter 4. Okay, so r is always going to come first and then theta, so just like x, y, those are in alphabetical order. R, distance from the pole, theta is our angle that we rotate from the polar axis. So we're going to plot the point 3 and then negative 3 pi over 4. So you can do one of two things. You can move out r and then rotate your theta, or you can rotate theta and then move out your r. I'm going to go ahead and rotate and then move out r. So I'll show you what that looks like. So remember, we are always rotating from the positive x-axis is what we like to think of it, but it's our polar axis. Okay, so to rotate negative pi over 4, we would end up here along this line right here. Okay, we're not going to make a line. I just know that that's where I need to move along. Okay, now my r is 3, and so from that negative 3 pi over 4, I'm going to move out from our pole 3, and there is that point. Okay, now the 3 additional polar representations of this point, okay, I could also say that we rotate a positive 5 pi over 4 to get to that spot and move out 3. Okay, it is also possible to have a negative r value. So if we rotate to pi over 4 and then move backwards 3, then we would get to that same point as well. Okay, so it is possible to have a negative angle and or a negative r value. Okay, a negative r value just means you're going to move backwards from where you are instead of forwards, like you saw me when I plotted that point right there. So we need to be able to convert from one form to another. So here is our conversions to go from polar to rectangular and rectangular to polar. So as you go ahead and look at these, let's talk about why they make sense. So here I have a coordinate plane. Okay, here I'm going to plot a point in the first quadrant just to make our picture a little bit easier. Okay, now for a polar coordinate, we would talk about this length right here being r, because that would be our distance from the pole, and then this right here would be our angle theta. That's how far we rotated. Now, if I'm talking about in our rectangular coordinate plane, then we would say that we move horizontally from the origin x and vertically from our origin, or from the origin y, okay, or vertically from that point y. And so here we have a right triangle. Okay, so let's look at this a little bit more. If I look at x, x is the adjacent side. So we say that the cosine of theta is adjacent over hypotenuse. And so that is how we get x equals r cosine theta. We also can look at y, that is the opposite of theta. So the sine of theta is opposite over hypotenuse. If we solve for y there, that is how we get our y conversion. Y equals r sine of theta. Okay, so if you have a polar coordinate, you can simply just use these two conversions to get your xy coordinate, or your rectangular coordinate. Okay, now let's talk about the rectangular to polar. All right, since y is our opposite side of theta and x is our adjacent side, we can say the tangent of theta is y over x. Okay, so then to solve for that angle, we can use our trigonometry knowledge. All right, and then for our right triangle, we can obviously use the Pythagorean theorem, x squared plus y squared equals r squared. So if you have rectangular coordinates and you want to put them into polar, you're going to use these two to figure out what your angle is and what your r is. Okay, so we're going to do a couple examples. First, I'm going to give you a polar coordinate, 2 pi. Okay. And then we're going to put this into rectangular coordinates. So let's remember our conversions. X equals r cosine theta, and y equals r sine theta. So to find our x coordinate, we're just going to put 2 times the cosine of pi. The cosine of pi is -1, so our x coordinate is -2. For our y coordinate, we're going to take r times the sine of theta. The sine of pi is 0, so our y coordinate is 0. So in rectangular coordinates, 2 comma pi would be -2, 0. Now let's go to the other way. I want to talk about the coordinate -1, 1 in rectangular, and we want to put this 1 into polar. Okay. The first thing that you do need to think about is what quadrant this is in, because your points should reflect similar quadrants, okay? So we want this to be in quadrant 2 because I meant for this to be a -1, +1. Okay, so go ahead and fix that. We want this to be in quadrant 2. -1, 1 is in quadrant 2. So for r, we know that x squared plus y squared is r squared. So we're going to put in -1 for x, a +1 for y, and so we get 2 equals r squared. So we're going to say r is the square root of 2. Now technically we could say r is plus or minus square root of 2, but when you're solving for coordinates, I want you to go ahead and use positive r values and positive theta values just for grading purposes. Okay, the coordinates are also easier to think about when everything is positive. Okay, so we'll just say that r is the square root of 2. Now, to find our theta value, we know that the tangent of theta needs to be y over x. So y over x would give us 1 over -1. Okay, so when is the tangent -1? Well, we know this happens 2 different times in one rotation of the unit circle. We know it happens in the second quadrant, and we know it happens in the fourth quadrant. Now, let me draw your attention back up to here. We know we need to be in the second quadrant. So what angle? Tangent of theta equals -1. So our theta is going to be 3 pi over 4. So our coordinate is radical 2, 3 pi over 4. And we know that that is going to land in the second quadrant, so we are good. Here are some hints to convert rectangular equations to polar form. When we take an equation and we want to convert it, we need to use our conversion formulas like we would for a coordinate. For a polar equation, typically we solve for r. Okay, so if it's possible, you need to solve for r. If there is no r in the equation, then you would need to solve for theta. So first of all, let's look at this equation here. Okay, we all know that this is a circle with radius 4, all right, with our center at 0, 0. So what I see is we have x squared plus y squared here. Do we have something to substitute in for that? Okay, if you look back to your conversion formulas, you know that x squared plus y squared is r squared. Okay, so we know r squared is 16, which is the same thing as r being 4. So our circle equation is r equals 4. Okay, in polar coordinates, this makes sense because if we have a circle, then at every single angle, our radius or our length from the pole is 4. Here we have y equals x. We know r, we can substitute r sine theta. X, we can substitute in r cosine theta. Okay, we have an r on both sides, so we can divide by r and cancel those out. Okay, so now we have the sine of theta equals cosine theta. If I divide cosine theta over, we would have sine theta over cosine theta equals 1. And we know that that is the same thing as the tangent of theta. Okay, where is the tangent of theta equal to 1 at? Well, that happens at pi over 4. Okay, so here we have y equals x. We know that's a line that goes through a pole at a 45-degree angle. Okay, so this theta equals pi over 4 is representing a line going through the pole at a 45-degree angle. Here in our second example, okay, we have 3x plus 5y minus 2 equals 0. So our x, we know, is r cosine theta, and our y is r sine theta. Minus 2 equals 0. Now our goal, if we can, is to solve for r. So here I see two terms with an r, one with not. So I'm going to go ahead and move the term without an r to the other side. That way over here we can factor out an r from 3r cosine theta and 5r sine theta. So that now we can divide this over, and we know r is 2 over 3 cosine theta plus 5 sine theta. Okay, here are the last two examples. We are going to work backwards. Okay, here we have polar equations. We want them in rectangular. So you see r equals 2. We do not have a substitution for r equals 2. However, we could square both sides, and now I have r squared equals 4. We do have a substitution for r squared, and it's x squared plus y squared equals 4. And there is our circle. Okay. After a few days, you will begin to recognize that when r equals a value, it is a circle. We're going to talk about the graphs, and so later on that will be something that will stick out to you. But we did force it to become an r squared so that we could make the substitution. Okay, and then here we have theta equals pi over 3. If the angle remains pi over 3, that basically means we have a line through pi over 3, so we should get a linear equation here. Now, the only thing we know about theta is that the tangent of theta equals y over x. So what we can do is we can say the tangent of pi over 3 equals y over x. Well, what is the tangent of pi over 3? The tangent of pi over 3 is radical 3. So we know radical 3 equals y over x. And then if we multiply that x over, we have y equals the square root of 3 times x. And there's our linear equation. Okay. The key to these conversions is to look for the opportunities to make your substitutions and go from there. Here is your homework. Please make sure this is complete and understood. If you have questions, you know where to find me. I will see you on Thursday.